Hello everyone, welcome to our YouTube channel. This is our first video on educational purpose. Our topic is air conditioning in trains. Particularly, we have taken LHB courses. Our guide is Dr. Yogesh Padia, and we have four group members: Ruktesh Patil, me, Sahu Sujit, Bhavik Patil, and Riyank Wade. Disclaimer: this video is presented for educational purpose. We are the students of Don Bosco Institute of Technology, Kutla. This task is given to us as a part of our curriculum activity. The following are some of the LHB coaches in India. How air conditioner works. Evaporator. It takes the heat from the place to be cooled and transfer it on the refrigerant. The refrigerant turns into vapor due to heat. The vapor refrigerant goes into the compressor. The compressor increases the vapor pressure and temperature of the vapor refrigerant. This refrigerant then goes to the condenser where it gets cooled due to outside air. This reduces the temperature of the refrigerant, but pressure is still high. This high pressure, low temperature refrigerant goes into the expansion valve where the pressure drops and it then goes to the evaporator and the cycle continues. Refrigerant used in LHB courses R22. This was a commonly used refrigerant in the past. However, due to its ozone depletion potential, it is not used globally. R407C. This is a more environmentally friendly alternative to R22. It's a blend of three refrigerants R32, R125, and R134A and has a much lower ODP.
So now let's learn about how air conditioning works in trains and how it is powered. So two air conditioning package units or RMPUs, that is the short form for roof mounted packaging units, are provided on the roof of each LHB coach. And these two RMPUs are controlled by microprocessors, and they are placed on both the ends of the coach. So both air conditioning package units are controlled by a single microcomputer based controller, which is a mounted switchboard placed in the cabinet. Now this switchboard is powered by a normal battery. These air conditioning air units work in fully automatic mode. So there are three ways of charging these RMPUs. The first one is self generating, then the second is end on generation, and the third is head on generation. Let's learn each of them one by one. So the first way of powering the AC is by self generating method. In this method, a alternator is used. The alternator is mounted on a bogie transom that is under the carriage supporting the wheels. The alternator is driven by the rotation of the coach's axle through a V-bell drive. So the V-bell drive runs as long as the coach is in motion. It requires a minimum speed for the alternator. When the coach is stationary or running at less than the MFO speed, the entire coach load is met by a battery of 800 ampere capacity. Other accessories other than the air conditioning are run by a 200 ampere battery which is mounted under the coach frame. So the second method of powering the air conditioning units is by end-on generation method. In this, two or more power cars are positioned at the end of the train. These cars house diesel generators that produce electricity. The electricity generated from them is transmitted through a cable running along the entire train. The coaches are equipped with equipment to receive the electricity and convert it to power the onboard amenities like light, air conditioning, and other appliances. So the third way is head-on generation. Unlike the other methods, this one is under research and not yet used. Unlike end-on generation that relies on separate diesel generators, the head-on generation process utilizes the electricity directly from the overhead electric lines. So overhead electric lines supply electricity to the train through a pantograph on the locomotive. Inside the locomotive, a special transformer called the Hotel Load Converter (HLC) is used. It converts the high voltage AC power from the cable lines to usable voltage and frequency for the coaches, which is typically around 750 volts and 50 hertz. The converted electricity is then transmitted through the cable running along the entire train. Each coach is equipped with transformers and converters to further adjust the voltage and distribute it to power lights, air conditioning, fans, and other onboard animals. So the total cooling capacity of each LHB coach is 14 tonnage. As each coach is fitted with two RMPUs, the tonnage of each RMPU comes along around 7 tonnage each. The generator car that is used in the end-on generation process is provided with only one air conditioning unit. In double-decker LHB chair car, two units of 10 tonnage each are provided at both ends. Air-conditioned air is supplied via perforated ceiling in the passenger room, air conditioning of entrance areas, toilets, and pantry with return air.
So this is how RNPU looks like. There are several components in RNPU. Let's take a look. Coming to the compressor unit, two hermetic steel scroll compressors along with the CU pipelines are provided for two cooling circuits in each RMPU. Each compressor of minimum 3.5 TR capacity at 60 degrees Celsius, condensing at 5 degrees Celsius evaporating temperature, making total rating of AC package unit 70 R. So let's take a look at condenser unit. Two condensers with a copper tubes and pre-coated aluminum pins are provided for two cooling circuits in each RMPU. These are air-cooled and two axial fans, along with the motors, are also provided in each unit for the cooling of the condenser pins. In both units, they are fixed with anti-vibration mounting pads for reliable operations. Coming to the evaporators, two evaporators unit with CU pipes and pre-coated aluminum pins are provided for two cooling circuits in each RMPU. The evaporator is a heat exchanger where refrigerant absorbs heat from the air passing through the RMPU. The refrigerant, typically a low boiling point liquid, evaporates by absorbing this heat. As per the result, the air flowing over the evaporator coils cool down. Supply air fan and blower motor. Two twin-sucking radial fans for the supply air are also provided in each unit for the supply of cooling air. Two radial fans are used in a configuration whereas enters from both sides of the impeller for increased efficiency. Evaporator blower motor, which is a single motor, drives both fans, providing the power to move the air. Now, heating unit in RMPU. This heater element generates heat when supplied with electricity, warming the air passing through the RMPU. The heating coil is supplied with bismuth unit supply. Heater has following protections. As we can see in the chart, the first one is overheat protection switch for heater with 1 unit. And the second is ESTI1 carriage plus 130 degrees Celsius for ultimate disconnection of a power supply if the temperature reaches 130 degrees Celsius. As we can see, the pressure transducers, following pressure transducers are provided in RMPU for the protection and indication of various pressure LP, HP, high pressure and low pressure parameters while working of RMPU. They ensure safe and reliable working of RMPU. Air filters and protection. Air filter. Following air filters are provided in RMPU for the filtration of air at various locations while working on RMPU. They ensure clean air supply. Material is progressively structured, non-woven break resistant, thermally bonded fire retardant. Synthetic materials in the chart we can see. Now, in protection, low power and high power cutouts have been provided in the refrigerant circuit for protection in case of low pressure and high pressure respectively. In humidity control, relative humidity is controlled inside coach by RMPU and is monitored by hydrostat, which is range 30 to 100% of relative humidity, located at a return air duct. NTC type sensors. There are three NTC type temperature sensors for each RMPU, which includes total six number of sensors per coach, are provided to control the temperature inside the LHB AC coach. The location of temperature sensors are one return air, one supply air, and one air duct in one RMPU. These references we are taken from Indian Railways. Thank you.